Hi friends, this video we are going to talk about representation of linear transformation by matrix. We know that the multiplication of m by n matrix with a column vector n by 1 gives a linear transformation from Rm to Rm. That is, A is a m by n matrix. Okay, it's multiplied by vector x is vector is n by 1. So it belongs to, it is a form a one linear transformation from Rn to Rm. We already know that. Yes. So my idea is we can convert any linear transformation into matrix multiplication we can provide or not. That is, we are going to check. Okay, it's theoretically we can do it. That is, we are going to discuss. So one more point also, we know that any linear transformation from V to W is completely determined by its action on a basis of V. So this result everyone know that. Okay, whenever we introduce a linear transformation, from the any linear transform is completely determined by its action on a basis, we already know. So these are the key idea. I am going to make every linear transform as a matrix multiplication. Okay, we start with our procedure. Suppose I am going to talk about I take one linear transformation from T, from V to W, be a linear transformation from an n-dimensional vector space V to an m-dimensional vector space W. Take an ordered basis alpha, that is V1, V2 and so on, Vn is a basis for our vector space V, domain vector space, and beta is another basis, W1, W2 and so on, Wm for W. So I have the two bases, for one for V, one for W. So from any linear transformation completely written by its action on a basis of V. This result we know that. So now I am going to try. So T of V1. Okay. So it belongs to W. So I can represent as by unique representation I can give. So that is I took namely A11 W1 plus A12 or 21 we take, that is much better for time being, W2 plus A31 W3 and so on. A, because W is the M, so A M1 W1 Wm I can represent, yes, because W is our basis and TV1 belongs to W, so I can uniquely represent this result. So similarly TV2, so commonly I taken as TVJ. TVJ equal to A1J W1 plus A2J W2 and so on, AMJ WM. We can represent, correct? So this can be written in the form of summation notation. I can write here where is from the first things. So I can write as I equal to 1 to M Aij times Wi. That is TVJ I can represent. So from clearly you know that what is the A1J, A2J and so on AMJ. We from the coordinate vector, so we can write it as TVJ as suppose beta is nothing but that is your coordinate vector, correct? What is your coordinate vector is A1J, A2J and so on AMJ. So this is, we know that this is a coordinated vector of TVJ on the basis of beta. So you don't know what is the coordinate vector. I already posted a video. I will give in the description link also. If you want, please watch it. Okay, this is the coordinate vector I can represent. Now any vector, now this is in the for linear transformation. Now one more thing, any vector x belongs to V, I can represent as, how I can represent x equal to summation j equal to 1 to n, because V is a n-dimensional vector space, so it's a base of V1 to V1. Here also you can uniquely represent by xj times Vj, you can write. So now you want to write a Tx, okay. So Tx means what you can write? Tx means j equal to 1 to n xj times T of Vj. From the, because T is a linear transformation, so I can represent this way, we can represent. Now we know that what is the Tvj? We already Tvj is, here I can represent summation I equal to 1 to m Aij Vi. That is a clear idea. I can apply j equal to 1 to n xj times summation I equal to 1 to m Aij times Wi. Now I multiply this guys inside, so then I can rewrite I equal to 1 to n and summation j equal to 1 to n xj times Aij times wi I can take. Now these three are now numbers I can complete summation I equal to 1 to m summation j equal to 1 to n aij times xj times wi I can write. Clearly we can write, correct? This is the key idea now. Now tx, this is my tx. Suppose this is also belongs to my vector space w. So these are the quant vector of tx. The bases are beta. So I can write as tx beta. What will come? This is simply quant vector of summation j is equal to 1 to n a. Here I is 1 first con. So 1 j times xj. Second element is summation j is equal to 1 to n a to j xj and so on. Summation j equal to 1 to n a m j times xj. This is the quantity vector of tx beta. So this one is I can represent very simply in terms of the matrix, correct? A11, A12 and so on, A1n, correct? Similarly A21, A22 and so on, A2n. So this process we can AM1, this is come to AM2, AMN times the vector x1, x2 and so on, xn. This is my tx or t of x, correct? We can write it. So this meaning is if I take this is the matrix A, this is quantity vector of x alpha, quantity vector of x. So what is the matrix A is it's a column vector of, this is nothing but, so this guy is, from our point we know that t of v1 beta, this is t v2 of beta, this is t v n of beta. Clearly, correct? This is the quantity vector of the first tv1, tv2 and so on. This matrix we call as a associated matrix or the linear representation of linear transform by the matrix. That this is the matrix. Okay, so this is matrix representation of t. So what is whenever they give the t is a linear transformation, you simply find the basis, you know the basis, you find the quant vector of the basis elements, then you write in the column wise. This is the matrix representation of t. Okay, so people always notice t is because alpha beta equal to a. Here alpha is the, where alpha is the basis of domain space. Domain space, that is, then beta is basis of codomain space. Okay, that is basis of V, this is basis of W. Please keep in the mind. Yes. Now we see few examples. Then clearly you got the idea. Damn sure you clearly get the idea once you understand this example. Okay. First we see, start with a simple example. Okay. First example. So my T is a from polynomial space to with the field is R to P2 of R. So this is both are from both spaces are same. Be the linear transformation. Sorry, this one you take not P2, you take P1. Is the much be the linear transformation defined by T of P of X is nothing times X times P of X. This way only we define. Okay. We take alpha is basis of P1 spaces 1 comma X and beta is 1 comma X square. Okay. For these are basis for P1 of R and P2 of R respectively. So find the associated matrix for T. So they given a linear transformation, they give the basis. Now we want to find the. So what is my first idea? I want to check it. What is the given? First step I want to write what are they given. What are they given? First start with given is, what is the alpha is the given? Alpha is 1 comma X and beta is 1 comma X square. Okay. So alpha means we taken as a V1, V2. This is beta is, this one is W1, W2, W3. Okay. So clearly V1 is 1, V2 is X. Similarly, W1 is 1, W2 is 2X and W3 is X square. So what I want to find from theory says, I want to check TVJ, correct? So first we will start with TVJ. So first I want to find TV1. What is the TV1 means? T of 1. The given polynomial is X times given polynomial. So I will get the X. How you can represent in terms of X in the W1, W2? 0 times W1 plus 1 times W2 plus 0 times W3. So what is the coordinate of T1? Coordinate vector is from beta 0, 1, 0. This is the coordinate vector of T of 1. Similarly, T of V2. T of V2 is T of x. So what is the answer? X times p of x. P of x is here x. So x times x. So you will get x square. So in terms of basis, 0 times w1 plus 0 times w2 plus 1 times w3. So this implies basis coordinate vector of t of x beta is 0, 0, 1. This is the coordinate vector. So the linear transformation, how I can write? A equal to t v1, their coordinate vector in the column wise, t v2 beta column wise, correct? So this implies the matrix is 0, 1, 0, 0, 0, 1. This is the matrix A. This is only our required matrix also. Okay, this example you can understand somewhat. Now we are going to non-standard basis also how we can find. We take another example. Say, let t from R2 to R2 be a linear transformation given by t of 1, 1 equal to 0, 1 and t of minus 1, 1 equal to 2, 3. Find the matrix representation of t of t of alpha of t. You have to find with respect to standard basis alpha equal to 1, 0 and 0, 1. Okay, so what they telling? They are given, first they give some points to map to some 2 points they given. They asked that your standard bases are alpha, your bases are standard basis they given. Now we are going to solve. How I can solve? So my first aim is I want to find what is my V1, what is my V2 and similarly W1, W2 like that. So from that, so they given both are same. So alpha equal to 1, 0, 0, 1. This is my alpha, this is my beta. So V1 is 1, 0, V2 is 0, 1 and W1 is W1 also same, W1 also 1, 0, W2 is 0, 1. So these two, first we want to find what is the domain space basis and codomain space basis we write separately. Next they given is what they given, t of 1, 1. correct? They given t of 1 comma 1 is 0 comma 1 and t of minus 1 comma 1 is 2 comma 3. So they are not given the basis. So I want to represent in terms of basis. So I require t of v1 and t of v2. But the problem they didn't give directly. So I want to find what is my t of v1 and t of v2. So I will find that I using the property of linear transformation. T of 1 comma 1. How I can represent t of 1 times v1. So first I want to try. So please wait. So I will write. They given is the 1 comma 1. Yes, 1 comma 1. How I can represent in terms of v1 and v2? 1 times v1 plus 1 times v2. I can write, correct? So this meaning, this one we know that. And similarly, second point is minus 1 comma 1. That point is minus 1 comma 1 is represented by minus 1 of v1 plus 1 times v2. I can write, correct? So now I apply the linear transformation of t of 1 comma 1 equal to 1 times t of v1 plus 1 times t of v2. Because linear transformation I can write directly, correct? Using the idea I can apply. So this t of 1 comma 1 is what we know that. So this is equal to 1 times t of v1 plus 1 times t of v2 is simply t of v2. So t of v1, v2 is given as 1 comma 0 comma 1. So they given as 0 comma 1. So this is in terms of w1, w2 I want to write, correct? So the 0 times w1 plus 1 times w2 you can write, correct? Similarly, t of minus 1 comma 1 is minus 1 times t of v1 plus 1 times t of v2. This is minus t of v1 plus t of v2. T of minus 1 comma 1, how are they given? 2 comma 3. This is equal to 2 comma 3. So this you can represent in terms of w1, 2 times w1 plus 3 times w2. I can represent, correct? Now you are taking these two guys only. So I will write this is the equation number 1. This is equation number 2. From 1 and 2. So from 1 I will write a t of v1 plus t of v2 equal to 0 w1 plus 1 times w2 minus t of v1 plus t of v2 equal to 2 times w1 plus 3 times w2. So you want to simply, this is the equation number 3, this is equation number 4. You just add these two guys, then you will get t of v2 equal to w1 plus 2 times w2, correct? And similarly t v1 is, you apply any one of the equation, you will get the answer is minus w1 plus minus w2. Okay, any one of the equation you apply, you will get the answer is this way. So what is the matrix A? The associate matrix A equal to t of v1 alpha, t of v2 of alpha, correct? This is the matrix A. What is the t1 v1 of alpha? Minus 1, minus 1. So minus 1 column wise, right? Similarly, t of v2 column is 1, 2. This is the matrix associated to the given linear transformation with the basis 1. I hope you understand how we are converting the linear transformation to matrix transformation. In upcoming videos, we can see few examples to understand that. Thank you for watching this video.